Okay, so hi guys, today we'll be looking at the problem find pivot index or find the equilibrium index. So basically what we have to do in this problem, let's read out the problem first. We're given an array of integers, nums, and we have to find the pivot index. What is the pivot index? A pivot index, basically it is the index where sum of all the numbers strictly to the right of the index are equal to the sum of all the numbers which are strictly to the index right. Sorry. So basically for an index I, the left hand side of this index, okay, and the right hand side of this index, the sum of all the integers of left hand side and right hand side should be equal, basically, and that is excluding the element at index I. Okay, if the index is on the left, if the index is on the left edge of the array, then left sum is zero. Basically, that means that if we have an array, let's suppose this, if I is here, then the left index is 0 because there is no element before this. And same is for here as well. If I is here, then right, the right, sum of the right hand side of this index is also 0. So, um, so we have to mm, um, provide the pivot index, and also we have to do it such that the leftmost pivot index should be returned. That means that if there are two indexes where the sum of left hand side and right hand side sum is equal, okay, then we have to return the leftmost of those, like the one which comes first. Okay, so let's try to think of a logic for it. Okay, so the first thing that we can see is basically, yeah, so it is a very simple and straightforward question. Okay, and it is actually a very simple answer as well. Okay, 136. Okay, the this is the example array. Okay, so for here, if we see, okay, the left hand side sum is L is 0, and the right hand is okay, just a minute. Yeah, so right hand sum is 7 plus 3, 10, 16, 21, and 27. Okay, okay, so yeah, okay. Mm, okay, what have we done here? Just a minute. Let me try to. Okay, okay, okay. Let me just write this in, you know. Okay, so we are given 1, 7, 3, 6, 5, 6. Okay, so that is the array that we are given, and let's just create. Okay, let me just make it so that. Okay, okay. So if we see, okay, so let's see the left hand side and the right hand side sum of, every index. Okay, so if I is 0, 1, 2, 3, 4, and 5. Okay, so this should be 0, this should be 0, because we already, you know, uh, yeah, as per this sentence that we read, the left hand side or the left sum for I equals to 0, starting is 0, and the right sum for the ending is 0. Okay, so the right sum for here is 7 plus 3 is 10, 16, 21, and 27. So this should be 27, right? Okay, now the left hand sum here is 1 because 1 is here. Okay, and the right hand sum is 3, 6, 9, 5, 14, and 20. Okay, okay, now the right hand sum is 8, right hand sum is 6, 5, 11, and 17. Okay, now the left hand side sum is 11 and the right hand side sum is 11 as well. Okay, and so yeah, let's just yeah, continue to do that as well. So it will be 11, 16, and this will be 22, and this will be 6. Okay, so we can see clearly uh, that we have got the index that we want, where LHS is equals to right is left sum is equals to right sum, and that is the index 3. Okay, so basically what we can see here is a pattern that, you know, the index, sorry, the sum, left sum at the starting index was 0, then left it was 0 plus 1, you know, then to the right it was 0, oh, left hand sum plus the previous element, and so on and so forth. Okay, and for the right hand sum it was at the starting it was the sum of the whole array. Okay, if we take sum of the whole array, it would be 28, so it was sum of the whole array minus the current element, because we have to find strictly greater. um, okay, uh, we have to find the sum where I index value is not taken into consideration. So 28 minus 1 was 27, and 27 minus the current index 7, that was 20, and so on and so forth. Okay, so what we can see clearly is that there is a pattern to left hand sum and right hand sum, and what all we need to do is at every index we have to compare these two, and it's a very straightforward answer, that where we find uh, the index where we find these two to be equal, we have to return that first index. Okay, so let's see how we can code that out. Okay, it is a very simple solution as well. So what we'll do is we'll take the right sum and we'll take it to be the sum of the whole array. Okay, we'll just do that. So we have found that 28 here. Okay, we'll take the left sum and we'll put it to 0. Okay, now for number, for I comma number, or for I in range length of nums, what we'll do is basically we'll first of all we'll right sum the right sum will be equal to, we'll remove the ith element from the right sum or the total sum, so that will be uh, nums of I. So we have converted it 27 8 to 27. Okay, and the left sum will be, you know, the left sum will be what it is already, because we don't need to add the ith element. So now we will say that if left sum equals to right sum, okay, then we'll return, what we'll return is the I index. Okay, and after that we'll just increment the left sum as well, which will be with the current element. Okay, and then we will return. Okay, and let's suppose this for loop is, for loop ends and we do not find anything in where left sum is equal to right sum, and we henceforth nothing was returned. We'll just return at -1 at the end, because if no such index return exists, we have to return -1. Let's just run this. Should be the very straightforward answer. Yes, and it is a right solution, and it is a very optimal solution as well. So, thank you everyone for watching, and yeah, do check out other problems in the playlist as well. The link will be at the end of the video. Thank you.